how about we have the following? We say that same, we're going to ask you to solve. Question that asks you to solve is negative 2x plus 2 minus 3x equals to 8x plus 20 minus 7x then. Now, you finish it, you finish copying it, or at the same time now you're copying, and I'm going to ask you one thing. Throughout the whole course, you helped me, I helped you to solve the problems. I always ask you questions like this. I will ask you like, how many terms? Be more specific, I will ask you, how many terms on the left, how many terms on the right-hand side? Because the how many terms is going to be asking you if you can identify the number of terms correctly. You already formed the strategy to solve the problems there. Now, what does that mean by terms? Here is another fun way to know these things about them. I can take this one away, but it's not going to help much. I don't have that much space anyway. So let me tell you one thing is, in the past we say that, oh, we learned 4 basic operations: plus, minus, multiply, and divide. And we always think that they are all 4. And already, even though that we say that they have some priority sense of like multiply, divide is higher than add and subtract, but that's all. But now I'm telling you that there is actually another big way to tell the difference between the add and subtract comparing with the multiply and divide is the following. When I ask you how many terms, okay? How many terms here? When the question I ask you how many terms, the terms here means, okay, terms are separated by plus or minus sign. As a matter of fact, plus or minus sign plus and minus signs are called the separator. Okay? So that means what? When you start reread again like this one, let me just rewrite the left-hand side. I have minus 2x plus 2 minus 3x just on the left-hand side. When you're reading it, you should see the following. This is negative 2 times x, and this is 3 times x here. Okay? We are just telling you that I have a portion of x, 3 times of that portion of x. This here is also x, and 2 times of that portion of x. It's a multiplication relationship. And then, the second thing I want to point out is this. You see that there are a symbol of minus sign, same color, doesn't make sense, right? It will help you to see that. So let me bring another color. So I have this sign here, this sign here, this sign here. These two, I will read it as an add. I will read this as a subtract. So they are separators. This guy here, I will not read it as a subtraction. I will read it as a negative. And it's not a separator. So what does that mean? It means that I have a plus and a minus sign here. So there are 2 separators. Separating what? Separating 3 items. First item is a minus 2x or negative 2x, be more precise. I have a first term is a negative 2x. Second term is just a 2. And then the last term is a 3x. How they are related? A plus sign and a minus sign. We're adding the 2 with the first one, and then we're subtracting a 3x from the result of the first 2 there. So there are 3 terms, separated by 2 separators, plus sign and minus sign. This does not count as a plus or minus sign, counts as a negative sign here. Okay? Whenever you see a minus sign in the front, I will always say that's a negative. I don't count as a separator, unless you rearrange the order, but this is how it looks. So we have 3 terms here, okay? So now we have 3 terms. Now we can go back and ask ourselves that group-like terms. What does it mean by group-like terms? If they are of the same kind, we can simplify them than adding or subtracting. Are these 2 terms same kind?
No.
This one bearing an x, this one has no x, right? How about the last one? Also have an x.
Yeah.
Now let me tell you how to tell the difference, because linear equations has only two kinds. The first kind is having an x, the other kind is the having no x then. Now why they are not the same kind? Think about it. If x equals to 5, then I have negative 2 times 5 is a negative 10. I have the values. If this is a 5 also, it's 3 times 5, I have a 15, right? But when x is equal to 5, does it change this value here? No. No, it's a constant term. It's not going to pick up anything because of the x change. If next time the x change into a negative 2, then you put it here, negative 2 times negative 2, you have the values which is a positive 4. And then this is 3 times negative 2, you have a negative 6. So every time you have different values of x, the first term and the last term change. They are of the same kind. This guy is a constant term. It does not change when the x changes it. So that is a different type of items. So you should not group them together. So now we're grouping the first and the last together. We have negative 2x minus 3x. So what you can think of this way now. So like this. Let me complete that. This is 8x plus 20 minus 7x. So what I'm going to say that group the like terms. Now this is an optional step. You don't need to if you don't want to. Is to say that I put them closer. Negative 2x minus 3x plus 2 equals to 8x minus 7 plus 20, like that. So what I did is that I'm not changing anything. I'm just putting the like terms closer to each other so that we can see them easier. So now we have, you can see that the plus 2 is still, the 2 is still associated with the plus and it's put at the back. And then the minus sign is still associated with the 3x and it's going to be put in the front or to the middle. So now we have negative 2x minus 3x. So how many x that we have? Negative 5x. You start with the negative numbers, you subtract that, it's going to be more as a negative 5x. So we have a negative 5x here. And then we add 2 is equals to, these two can combine just like these two can combine. 8x minus 7x is a single x plus 20. That's what we call group the like term. Okay. Now group the like terms is a step that I will say that when you're doing it has a higher priority than the add multiply properties of equality, because group like terms happen on one side each. You only group the items on one side. You are not throwing anything to the left side, right side yet. So you just settle with the left side to the least complicated version that you have. Same thing happened to here. The 3 terms that we have now, we consolidate them into 2 terms. All right, so now we have a negative 5x plus 2 equals to x plus 20. Now here comes the next step, fun part of it is the following then. The next step we're supposed to do, I think that many of you learn, is to say that we always want to have our x on the left-hand side. Means that you're going to say, oh, now I'm going to use the add or subtraction property to move the x one way to the other, so that I move the x to the left-hand side, and so I will put all the x on the left side, things like that. Now, but I'm teaching you or introducing you a new way. If you don't know what I'm talking about, just go back to your old way as long as your old way work. If it's not, it's a time to learn a new method. And I'm using one method that will be able to help you to solve equation and also solving inequality. One size fit all. Try to do that. It's not going to be hard. It's just a one little priority sense that we're going to ask about that. Now, what is the number in front of the x here?
Negative 5.
Negative 5. What is the number in front of this x?
1.
Is 1x, right? All right. So if you want to write 1x, 8x minus 7x is 1x, that's fine. So now on the number line, I have a number line, right? You've seen the number line before in your whole life, yeah? Okay. Now, so you have a 0. This is 1. This is a negative 5, right? So this is a negative 5. This is a positive 1. Whichever is more to the left is smaller. Do you agree? The number that is more to the right is greater. So if I have a number to the right side of 1, let's say a 3, 3 is greater than 1 then, right? 1 is greater than 0. So whatever the numbers on the right side is always greater than the numbers on the left side. So this guy is a smaller number. So my rule is I always pick on the one that is smaller, and we aim to get rid of it. How to get rid of it? Reverse order of operation. If I see minus 5, I will add 5. All right? So instead of moving everything to one side as a fixed rule, my rule is to say that whenever you see -5 and 1, whoever's smaller, get rid of it. How to get rid of it? Say that you're not going to be able to stay here anymore. You'll be moved to the other side, like that then. So -5x, I need to do the opposite. I'm adding a 5x on both sides. So that this is gone, I will have a 2. I have a 2 here on the left, and it's equal to 1x plus 5x is going to be 6x plus 20. The reason I do it now, as you can see, is I always ending having a positive portion of x there. You will not have a negative numbers. Why? You say that there's no difference. Yes, there's no difference. But later on when we are doing inequality, if you have a negative portion of x, you have to flip sides and you have to memorize the rules. There's too many things. If you're using that, you'll never see a negative x. You never see a negative x, you never need to worry about the other rules. Okay, so now what we have 2 equal to 6x plus 20, which is very similar to that, the first example that we have, because now I'm just copying it. 2 is equal to 6x plus 20. The only difference is that I have 2 terms on the left, 1 term on the right side. I don't know my left right. 2 terms on the right side, 1 term on the left. It's just kind of the flipping process of this, right? 2 terms on the left, 1 term on the right. Otherwise, it's the same. So what we're going to do is, I'm going to see that the x is being bothered by our multiply by 6 times and then adding 20. So we should get rid of the 6 first or get rid of the 20 first?
20.
Get rid of the 20 first. So we're going to subtract 20 on both sides, so that I'm going to have a negative, oh, we worry about that. This is gone, so that I'm going to have equal to 6x here. So this is what? 2 minus 20, right? 2 minus 20. So that one is positive, one is negative, so you know that you're going to look for the difference. So 20 and 2, the difference is an 18. Then you notice that the 20 is the negative, so that would be dominating the sign, so it will carry to the minus 18 then. So you have a negative 18 equal to 6x, so now you can take care of the last step. You do the reverse of the multiply 6 times, so it's going to be divided by 6 times. So you now end up having this get cancelled out, so that is equal to x on the right side, and then the left hand side is a minus 3. That's it. X has a solution set of negative 3. Is it hard? It's not. I don't think so. Well, by the time you say no, it's not hard, so let's complete our cycle of the strategy of solving the linear equations with 1 bar. So the last, it's not the last actually.